For decades, doctors believed they had stomach ulcers completely figured out. The cause seemed obvious, almost common sense. Stress, spicy food, a hectic life. It was the kind of explanation so widely accepted that no one thought to question it. Medical textbooks repeated it, specialists taught it, patients heard it, and the world moved on, certain the mystery was solved. But science has a habit of hiding its biggest surprises in places everyone has already stopped looking. Because somewhere, quietly, evidence was beginning to surface that something didn't fit the story. A few strange observations, a pattern that shouldn't exist, and one unsettling possibility. What if everything experts believed about ulcers was wrong? At first, it didn't look like a breakthrough. It looked like a flaw. While examining stomach tissue samples under a microscope, Rob and Warren kept noticing tiny curved shapes clinging to the lining. They weren't supposed to be there. The stomach was believed to be too acidic for bacteria to survive. That was basic medical doctrine. So, the simplest explanation was contamination, a lab error. Dust on the slide. Case closed, except it kept happening. Different patients, different samples, same strange shapes. Most specialists would have dismissed it as coincidence and moved on. But there's a moment in every real discovery when curiosity refuses to stay quiet. And Warren couldn't ignore what he was seeing, because the more slides he checked, the less accidental it looked. That's when the mystery deepened. The images alone weren't enough to challenge decades of medical certainty. He needed proof, patterns, something undeniable. Enter Betty Marshall, a young doctor with a sharp mind and a tolerance for unpopular ideas. When he saw the samples, he didn't see contamination. He saw a question no one else had dared to ask. What if these bacteria weren't accidental visitors, but residents? Together, they began tracing patient records, comparing symptoms, lining up evidence piece by piece, and slowly, an unsettling pattern emerged. The people with the worst stomach inflammation almost always had the same microscopic invaders. Not sometimes, not occasionally, consistently. If that connection was real, it meant medicine wasn't just slightly wrong. It meant it had misunderstood ulcers entirely. Their first challenge wasn't proving they were right. It was proving they went wrong. The prevailing theory said ulcers came from stress and lifestyle, so the obvious step was to test the alternative explanations. Maybe the bacteria appeared after the inflammation, feeding on already damaged tissue. Maybe they were harmless hitchhikers. Maybe they had nothing to do with the disease at all. So they tried to grow the organisms in the lab, and failed. Again and again, nothing grew. Cultures came back empty, reinforcing what everyone already believed. There was nothing there to find. For a moment, it looked like the establishment had been right all along. But science can hinge on timing, and one overlooked detail was about to change everything. The turning point came from something almost embarrassingly simple. Timing. One batch of culture dishes had been left untouched over a long holiday weekend. Far longer than usual. When the team returned, the plates they'd nearly thrown away were suddenly alive with growth. The bacteria hadn't failed to appear before. They just needed more time than anyone had ever allowed. In that quiet lab moment, everything shifted. What was once dismissed as absence was now undeniable presence. And if you're starting to feel the weight of what that means, stay with me. Because this wasn't just a lab success. It was the first real crack in a medical belief the world had trusted for generations. What made the discovery truly unsettling was Santi. Just that bacteria were present. It was where they were living. The human stomach was supposed to be a biochemical furnace, a place so acidic it could dissolve metal. Entire generations of scientists had accepted that nothing could survive there long term. And yet, here was living proof, multiplying calmly in the very environment thought to destroy it. This wasn't a small correction to medical knowledge. It was a direct contradiction. If these microbes could endure acids strong enough to break down food, then something fundamental about the stomach's biology had been misunderstood. And that raised a far bigger question than anyone expected. If they could survive there, what else could they do? There was only one way left to prove it, a test so direct no one could argue with the result. And it was Barry Marshall himself who decided to take it. In a move that sounded more like a dare than an experiment, he prepared a broth filled with the bacteria they suspected and drank it. Days later, the symptoms began. nausea, pain, the unmistakable signs of gastritis. Medical tests confirmed it. The same organisms had colonized his stomach, exactly as predicted. No stress, no spicy food, just microbes. In that moment, the debate stopped being theoretical. The question was no longer if the bacteria caused the disease, but how the medical world had missed it for so long. The explanation, when it finally came into focus, was both elegant and shocking. The bacteria weren't just surviving the stomach's acid, they were neutralizing it. By producing an enzyme that breaks down urea, they created a tiny protective cloud of ammonia around themselves, a chemical shield that let them burrow safely into the stomach lining. What once looked like an impossible environment was, for them, a carefully engineered habitat. With that mechanism understood, the entire mystery snapped into place. Ulcers weren't simply the result of stress or diet. They were, in many cases, infections, and that meant something revolutionary. Instead of lifelong medication, many patients could be cured with antibiotics. What stunned the scientific community wasn't just the discovery, it was how long the truth had been sitting in plain sight. For years, researchers had seen the bacteria in samples and dismissed them as irrelevant. The evidence had existed. The microscopes had captured it. But certainty is a powerful blindfold, and medicine had been convinced it already knew the answer. When Barry Marshall and Robin Warren presented their findings, many experts resisted, not because the data was weak, but because it overturned decades of accepted teaching. It wasn't just a new theory. It was a reminder of something science rarely likes to admit. Sometimes the biggest breakthroughs don't come from new evidence, but from finally believing what was already there. The final confirmation didn't arrive with applause. It arrived with time and results. As more studies repeated the findings, as more patients recovered with antibiotic treatment instead of lifelong medication, resistance slowly gave way to acceptance. The idea that once sounded absurd became medical standard. Textbooks were rewritten. Treatments changed worldwide. And what began as a strange observation on a microscope slide reshaped how doctors understood one of the most common diseases on Earth. Years later, the discovery would be recognized as one of the most important medical breakthroughs of the century. But the real legacy wasn't the awards or recognition. It was the lesson behind it. Certainty can be dangerous, even in science, because sometimes the truth isn't hidden. Sometimes it's been visible all along, waiting for someone curious enough to look twice, question the obvious, and refuse to ignore what everyone else already decided couldn't be real.